Welcome to this tutorial on loudness and metering. Loudness is closely related to amplitude and volume and an important consideration when mixing and mastering finished music and dialogue. Unlike volume, which describes amplitude at a moment in time, perceived loudness is about how we experience volume over time. Loudness is therefore about perceptions of average volume or level. In recent years, there has been much concern about sound engineering work practices relating to loudness, where marketing is an important factor in decision making. Advertisers and record companies have been preoccupied with attempting to make their recordings louder than their competitors. Because peak level restrictions are imposed by recording playback and broadcasting technologies, they have tried to use narrow dynamic range and peak level maximization to increase perceived loudness. The primary tools to achieve this are compression and limiting, and the practice is therefore often referred to as dynamic range compression. There are four primary problems with these work practices. Firstly, other content creators such as filmmakers, television program makers and classical music record companies favour recordings with a wide dynamic range, which means their products have much lower average loudness levels. This means that listeners must constantly readjust volume level when switching between recordings or when watching program material such as films and documentaries, which are interrupted with commercial breaks. Secondly, recordings with narrow dynamic range and which have been peak level maximised can be very fatiguing to listen to. Thirdly, many of the loudness maximisation work practices produce very distorted finished products which spoil not only the nuances of dynamics but the harmonic content of the sounds themselves. And lastly, if a program of tracks, such as an album, contains both aggressive compositions and ballads, then the ballads can end up sounding disproportionately loud. There has therefore been a movement towards defining some standards for measuring and metering loudness, and defining agreed loudness levels for recordings. Before we look at the implications of loudness metering for project studio owners, let's look at what happens when different types of content are processed for loudness by a broadcaster either before or during playback or broadcast in order to ensure a more consistent loudness experience for the listener. Broadcasters and playback technologies are increasingly introducing methods of correcting loudness differences during playback. Examples include TC Electronics' range of real-time loudness processors and Apple's SoundCheck algorithm for iTunes. After being subject to loudness correction, any content that has been heavily processed during mastering to be loud all the time now sounds quieter, duller and less interesting than the content which has maintained its dynamics. If playback technologies and broadcasters adopt the new loudness and metering standards, and they are, there will be little point in content creators trying to make their content louder, and they too will have to adopt the same loudness metering standards during mixing and mastering. So let's look next at what we can do to ensure our recordings conform to new loudness standards and will not be subject to processing or rejection by broadcasters. In the past, the studio engineer has relied on two technologies to look at volume level: peak program level meters and VU or volume unit meters. Peak program level meters or PPM meters display the peak level of signals in audio equipment. There are many types of PPM and they all help the studio engineer to determine the peak levels in a sound wave signal. One type of PPM is the true peak program meter, which displays the changing peak level of a sound wave signal. They are used to identify the loudest peak in a signal. Another type are sample peak program meters, also sometimes referred to as digital meters, which display changing peak sample values. These types of meters are used in digital mixers, effects processors and DAWs. Good practice dictates that when using these types of meters, 3 decibels of headroom should be allowed to accommodate inter-sample peaks and avoid distortion. A peak level of -3 decibels is therefore required. Neither true peak program meters or sample peak program meters are useful for displaying perceived loudness. What is needed is a form of metering that can show both peak levels and a history of loudness over time. The VU meter was developed in 1939 to display signal level in audio equipment. Due to the ballistics of its meter, it is unable to show peak levels or spikes in volume. It is therefore not good at showing peak levels. Interestingly, this limitation makes it better at showing average level, which is loudness, and this explains why it has remained popular. However, the VU meter cannot tell us what a recording's average loudness is over its duration. There have been serious challenges in developing a method for measuring loudness, and perhaps the greatest is the variety of factors that affect its perception. Firstly, we all perceive loudness differently. Whilst there isn't much we can do to address this, and it isn't the most important factor, it is important to acknowledge it. Secondly, loudness perception changes depending on the environment. For example, if the background noise is very loud, such as in a car or on a flight, we are more accepting of higher loudness ranges. Thirdly, loudness perception depends partly on the mood or tiredness of a listener. Because of factors such as these, loudness metering must be predicated on average loudness perception. Despite these limitations and many other complications, loudness metering is still a valid and useful way to arrive at a good, equitable and natural dynamic range and loudness, and ensure that level differences between advertising, music, film and video are minimized. Loudness metering can be a confusing and complex subject, so we are going to simplify it and give some practical advice. The new standard for measuring both loudness and peak level is known as ITU BS 1770. ITU stands for International Telecommunication Union. BS 1770 is a specification that contains algorithms for loudness metering. This standard is used for a new generation of combined peak level and loudness meters, such as this TC Electronic LM2 loudness radar plugin. To use a plugin such as this, simply insert it on the master output. There are a few things to note. Firstly, loudness metering ignores momentary peak level signals, so it's good practice to keep an eye on these and ensure that ppm peak level does not exceed -5 decibels. Secondly, the basic unit for program loudness measurement is LUFS, or loudness unit full scale, and the target value should be -23 LUFS. Thirdly, it is useful to have loudness meters that display momentary loudness and loudness over time. This plugin provides a visual display of momentary loudness on the outer ring and loudness over time on the radar display. Excessive loudness is shown in yellow, acceptable in green, and low-level loudness in blue. The target loudness is at the intersection of the green and yellow rings. Fourthly, a single numerical program loudness display will tell you the overall loudness level. When you finish metering, you will want this to be as close to -23 LUFS as possible. Next, loudness range is measured in LUs and shows the variation in loudness. It can be used to judge if compression should be applied. Loudness range becomes important if your recordings are being targeted at a specific platform. For example, for home cinema you will want a wide loudness range of around 20 LU in order to maintain dynamics. But for in-car listening you will want a narrow loudness range below 8 LU to ensure all of the recording is audible. Next, loudness metering only works with minimum durations, so you should think about measuring loudness over the duration of a piece, or for no less than 20 seconds of average or loud parts of the program material. The LM2 uses a loudness history display that advances during playback. Here the loudness radar history is set to 4 minutes. The script for this tutorial, with accompanying screenshots, can be found at projectstudiohandbook.com. And finally, please don't forget to subscribe to our YouTube channel or at the website to get instant notification of new videos as they are uploaded. And please do click on the ads of interest to you. We're a free resource and they help to pay our costs. Thanks very much for watching.